Hello, Mr. Stolle here. So today we're going to look on number patterns, grade 10 number patterns, and we're looking at the common difference and also the common ratio. Okay, so let's just get to see what's going on. Now, you need to understand how number patterns works. So here we have got we've got numbers that are arranged. We've got the first term, the second term, and when we are naming this, we say T1, which is the term 1, term 2, term 3, up until Tn. And Tn, it means that is the nth term. Okay. Now, if we're having the nth term, it can be any term that we want. Okay. It can be any term that we want, and that's what we refer to as nth term. Let's say we have got 1, 2, 3, and 4. It goes on like that. These dots means that we are the pattern is still what called continuing. So we need to understand that it doesn't end, and we can be asked to find 100th term, 500th term, 10th term. There is no need for you to worry. Now we've got 1, 2, 3, 4. So this is our T1, the first term. This is our T2, the second term. Here is our third term. Now, at some point, you need to predict or to find what will be the what called 100th term, what will be the 10th term. What do you use? You have got certain formula that you use. Okay, so for now, the terms can have what you call a common difference. Can have a common difference. For example, what we have here, 1, 2, 3, 4. We have a common difference. If you say 2 minus 1, you get 1. If you say 3 minus 2, you get 1. So that's what you call a common difference. Okay, that's what you call a common difference. If you also minus here, you also get what you common difference. So if you are to be asked to find the 100th term, you also need to use a certain formula. So let's see here. The formula that you must understand here is Tn is equals to A plus n minus 1 D. Okay, so Ta plus n minus 1d. So here our A is our first term. A is our first term, okay? And our D is our common difference. Common difference. Okay, so the common difference, you find it by subtracting the terms. So how do you find D? D, you're going to say, let's say you're going to say T2 minus T1. You see what is the value, then you're gonna say also confirm T3 minus T2. You see, you subtract consecutive values. When you subtract consecutive values, if they give you the same value, same answer, it means that there is a common what you call difference. So in that case, you will be using what you call this formula for common what you call difference. Okay, T4 minus T3. It goes on like that. Now, let's see here how you're supposed to get the nth term, the general term. So general term, you use Tn minus, Tn is equal to A plus n minus 1d to find your general term. So this, you use it to find general term. So the general term or general rule, let me just use say general rule to find the nth term, you're gonna be using Tn is equals to A plus n minus 1 D. So here is a matter of substituting the value that you'll be given. Okay, so let's get to see here what we have. We've got first question here is 6, 9, 12, 15. So what is the common difference here? We have got, if we have to subtract this, if we say 9 minus 6, we get 3. If we say 12 minus 9, you get 3. If you say 15 minus 12, you get 3. So we have a common difference. So once we have a common difference, we know that our D, let's just use D is going to be equals to 3. Then our A is our first term. What is our A? Is 6. Okay. So what do we do now? We're going to say Tn is equals to A plus n minus 1 D. So what is our A? Is 6 plus n minus 1. Okay, D is 3. So in this case here, you're going to multiply 3 and take 3 inside. Okay, you take what you call 3 inside here, and I think based on the information that you have from your algebra, you only have a problem here. So it's going to be 6 plus 3 times n is going to be 3n. 3 times negative 1 is going to be minus 3. So now you can subtract these are like terms. You've got 6 and 3. They are like terms. They don't have any variable with them. So you can actually work them out. So here it's going to be 3n minus 3 plus 6 is going to be plus 3. So this is going to be your general term. So your general term always, general rule must have the n. The general rule must have the n, because we don't have a specific term that we are talking about. We are just saying general, what called rule that can find us any term that we want. So let's see here, they want us to calculate the 100th term. So general rule, the first answer here is sorted. It's the general, what called rule, we have it to calculate the nth term. Let's get to see here if we can get, what is it, the 100th term. Okay, so you're gonna say now T100. So remember, we have got Tn is equals to 3n plus 3. So when they say T100, you just substitute where there is n, you put 100. So it's going to be T100 now. Then it's going to be 3 in bracket 100 plus 3. Then 3 times 100 is 300 plus 3 is going to be 303. So this is our answer. What about if they say 20 term? Okay, let's say they want 20, what call term. What you're going to do, you're going to say T20 is equals to 3 in bracket 20 plus 3. Then 3 times 20 is going to 60. Then plus what call plus 3. Then it's going to be 63. That's going to be your value there. Okay, so that's going to be your answer. Let's see if we can go to the next question. So what did you master here? You master that you must write your formula first. You get your D, which is your common difference. You find it by subtracting the terms. Then you also look for the A. A is always the first term. So you just take the term, you put it as it is. You substitute D, which is the common difference. Then you can work it out. Once you get your answer, general term must have an N with it. Now let's look at this one. What I want you guys to do when we are doing, when I'm recording like this, when you're listening to recordings, try to do this one on your own. You see the one that we are starting to attempt now. Try to do it on your own and see if you can get it correct. Then you can just put your video in the pause, then you do it on your own, then you also see the solution if you're getting it correct. Now, let's see what we have here. 13 minus 9, what's going to be 13 minus 9? It's going to be 4. If we say 17 minus 13, we get 4. If you say 21 minus 17, you get also 4. So you have a common difference here, it's 4. So you're going to say D is, in this case, is going to be equal to 4. What is our A? Our A is not a problem because it's just the first term that we see. So it's 9. Okay, then we have our formula. Tn is equals to A plus n minus 1 D. Then what is our A? Let's substitute together. 9 plus n minus 1. What is our D? It's 4. Now let's take the 4 in. Let's take the 4 in. So it's gonna be 9 plus 4 times n, 4n. 4 times negative 1, negative 4. Then let's deal with the 9. Remember, 9 and 4 are like terms. It's always like this, so you don't need to stress much here. 9 minus 4 is going to be 5. So here it's going to be 4n plus 5. That's your general, what you call general rule. So your Tn is equals to 4n plus 5. You can use this formula here. You can use this rule here to get any what you call term that you want in the sequence. In this sequence, you can find any term that you want now. So you don't have to stress. So let's look at it if we can get it. Let's say T100 here. T100 is going to be equals to 4 times 100 plus 5. Okay, 4 times 100 is 400 plus 5, which is going to give us 450. and 5. What about the 30th term? Okay, let's look at the 30th term. We're going to say T30 is equals to 4 times 30 plus 5. 4 times 30 is equals to 120. So 4 times 3, 120 plus 5 is going to give us 125. That's our final answer. Okay. Now let's go to the next question. Now, on this one here, we are still going to do the same thing. But I want you guys to understand something here. We're going to do two methods here. We have general, what you call the common difference and common ratio, as you saw from the first slide. So what you're going to do now, we are still focusing on the common difference. So you need to check your values first. If they don't give you a common difference, it means that you have to use another method. So 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is going to be 4 as well. I want you to do this one on your own and see if you can get to the answer. Okay. Now let's look at this one. It's a bit different now. So what do you need to do? First, change to our improper fraction. So here we need to change it to improper fraction first. So what do we do to change the improper fraction? We times here, then we add. We times here, then we add. We times here, then we add. So what do we do now? We're going to say, okay, what is 2 times 2? It's 4. 4 plus 1 is 5. So it's going to be 5 over 2. That's our first term. 2 times 5 times 4 is 8 plus 1 is going to be 9 over 2. Then 2 times 6 is 12. 12 plus 1 is 13. So it's going to be 13 over 2. That's what we have there. So we've got, now, can you see what we're going to do now? We need to find the common difference. But how do you get the common difference here? You don't need to put in all the values here to say 9 over 2 minus 5 over 2. Treat the top as what is it? As the denominator on their own and the numerator on their own. So here, what I'm going to do, I'm going to just circulate this. Okay, this is constant. Can you see that? This is constant. So whatever term that you're going to have, we are going to have over 2 at the bottom. So this is going to be remain constant, but what is varying here is the top part. So the top part is what is changing. So here we need to focus on this, the top part here. We don't need to stress about the bottom, but remember to carry your denominator, your what you call your denominator always. So let's look at the numerators. 9 minus 5 is going to give us 4. 13 minus 9 is going to give us 4. So we are focusing on the top, what is it? The numerator only. You are separating, so deal with the denominator. So deal here, when you have a fraction, deal with the denominator or the numerator and denominator separately. So treat these separately. You don't need to work them together. Treat them separately, then you won't have a problem. So you just need to focus on the top and also on the bottom. So let's see what we're going to have here. We're going to say 9 minus, we have got D. D is there. D is 4. What is our A? Our A in this case is equals to, what is it? 5. That's what we have. So what's going to be our Tn? Tn is A plus n minus 1 D. Then what is our A? Our A is 5 plus n minus 1. What is our D? It's 4. So we take in the 4 there. It's going to be 5 plus 4 times n, 4n. 4 times 1 minus 4. Then you're saying 5 minus 4, what do we get? We get what we call 5 minus 4, you're going to get 1. So it's going to be 4n plus 1. So this is the formula. So general term now, let me just put it this way. General term is going to be 4n plus 1 Tn, 4n plus 1 over 2. So we've got over 2. So whatever we're looking for, if we are looking for the 100th term, what do? T100 is going to be equals to 400 plus 1 all over 2. Then what do we get there? 400. 400 plus 1 is 400 plus 1 over 2, which is going to give us 401 over 2. That becomes our 100th term. What about T20? Let's say T20. T20 is going to be equals to 20. Going to be 420 plus 1 all over 2. 4 times 20 is 80 plus 1 over 2, which is going to be 81 over 2. That becomes our final answer there. Okay, so always remember you treat these separately. So here there is no change in the denominator, so you don't need to stress. You don't need to stress about it, but you must make sure that when you write your final answer, the denominator must always be there. So when you put it like this, the 2 here, it means that it remains there. It's always there. It doesn't change. But what changes is only the numerator. Let's move on to the next question. Here is a different approach now. Can you see what we are given here? 4, 11, 18, 25 is given. Determine the 45th term. Which term of the sequence is 627? So can you see something here? This is something new. We haven't seen this before. So we also need to see how it's treated. Now let's have our sequence here. It's 4, 11, 18, 25. It goes on like that. Let's look at the differences here. 11 minus 4 is going to be equal to 3. 18 minus 11 minus 4. No. 11 minus 4 is going to give us 7. Then 18 minus 11 is going to give us 7. 25 minus 18 is going to give us 7. So we have got our D is equals to 7. Our A is equals to 4. What is our general term here? Tn is equal to, can you see, you are supposed to do, even if they didn't ask you to calculate the general rule, you need that's a prerequisite. You need to have a general term, a general rule first, so that you can get the this term that you want, 45th term. Then I'm going to say it's going to be A plus n minus 1 D. Then this is, what is our A? Our A is 4 plus n minus 1. What is our D? It's what we call 7. So we take the 7 in, it's going to be 7n minus 7. 4 minus 7, remember the like terms. 4 minus 7, what do we get? We get negative 3. So it's going to be 7n minus 3. That's the general term there. Okay. What about T45? Let's use something else here. T45 is going to be equal to 7 in the bracket 45 minus 3. What do we get? Let's see our calculator here. 7 times 45 minus 3, we get 312. So our answer is 312. Simple like that. Okay, now let's now see how do we attempt this? Which term of the sequence is 627? Now what are we given here? We are given Tn. So we're given Tn. So this is our Tn. This is our Tn. So we know the formula now, general rule, Tn is equals to 7n minus 3. So what is our Tn here? We substitute for, We substitute for, for Tn is going to be 627 equal to 7n minus 3. So when you say which term you are looking for n, so always when they ask you which term you are looking for n, so this one here is the n in question. Always remember that when they say which term you are looking, they are looking for what you call for n. Let's see what we have here. We're gonna say we take the 3 that side. Is when it goes that side is gonna be a positive. So 627 plus 3 is equals to 7n. And what do we do from there? We get what is it? Sorry, 627 plus 3 is gonna be 630. So it's 630. There's no need for calculator for that one. By 7n. Then here we divide by 7 to get rid of the 7 here, because we want to be left with what called with n. So it's going to be by 7 here. We divide by 7. Then it's going to be 630 divided by 7. What do we get? We get 90. So here we cancel and we are left with what to call 90. So here n is going to be equals to 90. So it's 90th term. That's what we're talking about here. So 9th term is the one that is going to give you 627. Okay, let's look on the next question again. We are given that it's 19, 16, 13, 10. Okay, it goes on like that. And can you see something here? There is a decreasing, but remember, we stick to our rule. What do? We get the difference. We get the difference, irrespective of which order, are they in the descending order or ascending order, doesn't matter. You get the difference and put it as it is. Now, 16 minus 9, you're going to get negative 3. 13 minus 16 is going to get negative 3. Then 10 minus 13 is going to get negative 3. So what is our D? Our D is negative 3. What is our A? Our A is 19. Okay. Now, how would you get our Tn? Tn, let's use another color there. Tn is equals to A plus n minus 1 D. Okay. So let's see what we're going to have here. Our A is 19 plus n minus 1. And in this case here, we are having negative 3. And negative 3, remember, we take it in as it is. We multiply there. It's going to be 19. Now, when you say negative 3 times n, it's going to be minus 3n. Then negative 3 times negative 1 is going to be plus 3. Okay, then what do we get from there? 19 plus 3 is going to give you 22. So it's going to be negative 3n plus 22. That becomes our Tn. So here, remember, it's part of the steps, but what we really want here is to get the 65 term. Okay, so we're going to say T65 is going to be negative 3 in bracket 65 plus 22. Okay, then what do we get there? It's going to be negative 3 in a bracket, sorry, negative 3 in a bracket 65, then plus 22. What do we get? We get negative 173. So it's going to be negative 173. That's our answer there. That's the T65. And it makes sense, as you can see also, because the values are descending, are decreasing, and it makes sense that our 65 term is going to be negative because we are going on the negative direction. Now, let's look on the next question here. Which term of the sequence is equal to negative 113? What is this? It's our Tn. What are they looking for? They are looking for n. So we know that formula Tn is equals to negative 3n plus 3, the general term. We use the general term that we already know, that we already found here, which is this one here. Why am I putting 3 there? It's supposed to be 22. Then here is going to be negative 113 is equals to negative 3n plus 22. Then we take the 22 that side. Okay, when you take the 22 that side, it's going to be negative 113 minus 22. What do we get? Negative 135. So we're getting negative 135 is equals to negative 3n. Then what do we do there? We divide by -3. We divide by -3 because when I get rid of -3 there, then we cancel here. Our n is going to be equals to, let's see what we get there. If we divide the answer here by -3, what do we get? We get 45. So it's actually 45. So our n is 45. N is equals to 45. And 45 what? Is a 45 nth term. That's what we get there. Okay. Let's move on to the next what called a problem again. Consider the number pattern 4 times 7, 7 times 15, 10 times 23, 13 times 31. So here again, what I want you guys to know, treat these products separately. Treat the products separately. Okay, so here we need to treat 7, 15, 23, 31 separately from what is it? From your 4, your 7, your 10, and your 13. So these treat them as two different sequences. So what I can just say here, let me just put this. So treat 4, 7, 10, 13. Understand? Then here we have got what? We are saying it's times 7. You treat also with 15, treat it separately from 15, treat it also 3, and also what you call with 31. So these are the sequence that you have. So you've got 4, 7, 10, 13. Then you've got 7, 15, 23, 31. So let's look on the first one here. We're going to say, okay, let's have the 4, 7, the 10, and 13. Let's see here what we have. Let's also, we're gonna look also on the next one here, which is gonna be what called 7, 15. But there's no need here, it's fine. 15, 23, and 31. Okay, if we have to look at them, let's see what we get as a common difference here. 7 minus 4, you're going to get 3. 10 minus 7 is going to get 3. 13 minus 10, you're going to get 3. Then let's look at this one. 15 minus 7, what are you going to get? 8. Then 23 minus 15, you're going to get 8. 31 minus 23, you're going to get 8. Okay, now what do we know now? A is equals to 4, and what is it? And D is equals to 3. Then here A is equals to 7 and D is equals to what we call 8. Now, how do we do now from there? We're going to say Tn is going to be equals to A plus N minus 1 D, and your Tn also this side. So we can just say Tn1, then you say Tn2 is going to be equals to A plus N minus 1 D. Okay, now what do we do from there? We're going to say Tn is our A is going to be equals to 4 plus N minus 1. Our D is what? Is 3. Then what do we get there? It's going to be 4 plus 3. We take it in. It's going to be 3n. 3 times -1 is going to be -3. Then here 4 minus 3 is going to be 1. 3n plus 1. So that's the first sequence here. Then what about the next one? Next one is equal to Tn. Let's use a different color here. Tn is equals to 7 plus n minus 1. What is our difference? It's 8. So it's going to be 7 plus 8 times n is 8n. 8 times negative is going to be -8. Then what we get from there is going to be 7 minus 8 is going to be 1. So it's going to be 8n minus 1. So that becomes our formula on the other side. So what are we just doing here? We are multiplying the 2. We are multiplying the 2. So how do we get our Tn here? Tn is going to be equals to 3n plus 1 in bracket 8n minus 1. That's our rule. Now let's just test it if we can get it. If we are actually coming all right. Let's just try to check here. 7 times 15. Let's check here. 7 times 15. 7 times 15. We are getting 105. So T2. So T2 in this case is equals to 105. So remember here we want to check. So let's say here T2 is going to be equals to 3 times what? Times 2 plus 1 in bracket 8 times 2 minus 1. Okay, let's see what we get here. If we say first bracket 3 times 2 plus 1, open another bracket, 8 times 2 minus 1, close the bracket. Can you see what we get? We get 105. 105. We get the same answer. So this is how you do it. So learn to do something here to separate. Whenever you're given fractions, separate them. Separate whatever individual numbers that you are given, separate your numerator and denominator. When you're giving these products, you must know that this factor that you are having, 4 and 7, and the next one, 7 and 15, separate them as well, so that you can treat them and deal with the 4, 7, 10, the first one, that the first multiples, you deal them separately. The second multiples also, you deal them separately. Then from there, you have your formula sorted there. So let's just get the T50 here. The T50 is going to be equals to 3 times 50 minus plus 1. Then it's going to be 8 times 50 minus 1. Okay, let's punch in our calculator. It's going to be, let me push it this way. Sorry. Okay, it's going to be equal to, we open the bracket here, 3 times 50 plus 1, we close, we open another one, 8 times 50 minus 1, we close. Okay, then what we get? 60,249. So it's 60,249. Okay, that's our final answer like that. So the trick about maths, guys, is that you need to understand the concept. You need to understand the basic concepts, and those concepts, you apply them to whatever you see. So whenever you see products here, you must know that I treat them separately. When you see fractions, you treat them separately. Let's move to the next question here. Now, this one here, if you say, let's try to do it here, 4 minus 2, we get 2. But if we say 8 minus 4, we are now getting 4. So it's now what we call a different story now. So we are now talking of what we call the common ratio. And the common ratio is where we say, if we say T from your terms, if we say T2 over T1, it's going to give you the same answers by saying T3 divided by T2. It's going to give you also the same answer by if you say T4 divided by T3. That's what we're talking about here. So if you divide these two, you are going to get the same what called ratio. So how do you get the general formula now? General formula is in the form of Tn is equals to ARn minus 1. AR to the power of n minus 1. So this n minus 1 is an exponent. Your A is equal to what called the first term. Okay. What about your R? Your R is a common ratio. So here is common ratio R. And how do you get your R? Your R is equals to T2 over T1 equals to T3 over T2 equals to T4 over T3. That's what we're talking about here. So let's see if we can get our R there. So we're going to say T2 over T1. So T2 over T1 is going to be equals to 4 divided by 2, which will get 2. Then what about T3? The second ratio is T3 over T2. This is going to be equals to 8 over 4, which is going to give us what we call 2. Then what about T4 over T3? What's going to give us? It's going to be 16 divided by 8, which is going to also give us 2. So can you see what we have here? We have got our R equal to 2. So our R is equals to 2. Our A is equals to what we call 2. So we have our values now. How do we get the general term here? Tn is equals to A R n minus the power of n minus 1. What is our A? Is 2. What is our, remember here, we have got 2 and in bracket n minus 1. Always, you don't multiply these 2 here, like 2 times 2. You don't do that. You first finish what you call with the exponent here. That's when you can actually come back and actually multiply. But let's see here if we can get T10. So T10, wherever there is n, you put 10. So it's going to be 2 times 2 to the power of 10 minus 1. Okay, which is the same as, which is equal to 2. Yeah, I'm multiplying here. So it's going to be n minus 1, which is going to be 9 here, because 10 minus 1 is 9. Let's see if we can get the answer here. So it's going to say 2 times 2 to the power of 9. Okay, then you get 1024. 1024. So never make a mistake of multiplying these two. You finish this first, then you can multiply what you call with also including the exponent. Let's see what you can get this side. So I've got 1, 3, 9, 27. What did we learn? We learned T2 divided by T1 is equals to 3 divided by 1, you get 3. Then T3 divided by T2 is going to be equals to what we call 9 divided by 3, which you also can get 3. Then what about T4 divided by T3? You are going to get what we call 27 divided by 9, then you get 3. So our common ratio here, our common ratio R is equals to 3, then our A is equals to 1. Okay, let's see the general term here. Tn is going to be equals to A R n minus 1. What is our A? Our A is our first term. It's 1. So it's multiplying what? R. R is 3. Then n minus 1, which is going to be just 3n minus 1, because 1, whatever you multiply with 1 is going to give you that value. So here you don't need to stress much. So what about T10? Let's see, T10 here is going to be 3 to the power 10 minus 1. What do we get there? 3 to the power of 9. And what is going to be your answer? You punch in your calculator. 3 to the power of 9, we get 19,683. So it's 19,680, what you call 3. That becomes your value. Okay, let's look on the next question here. We have got, for each of the following number patterns, determine general rule and hence the 10th term. So general rule, remember, we're going to see, okay, if we look at these values, if you say 12 minus, you always have to test it first. 12 minus 4, you get 8. Then if you say 36 minus 12, you are getting a different what you call value, which is bigger than that. So you can see that the common difference won't work here. What's going to work here? Let's try to see. T2 divided by T1 is going to be 12 divided by 4. What do we get? We're going to say 12 divided by 4, we get 3. So it's going to be 3. Then T3 divided by T2 is going to be equals to 36 divided by what we call by 12, which is going to also give us 3. Because if you say 36 here divided by what we call 12, you get 3. So here our common ratio, R is equals to 3. What is our A? Our A is equal to, what is it? 4, because that's the first term. So how do we get the general term? We're going to say Tn is going to be equals to A, it's 4. Okay, let's put the bracket here, 3 in bracket n minus 1. That becomes our general rule. Let's see what is the next thing here. We are looking at 10. So T10 is going to be equals to 4 in bracket 3, 10 minus 1, which is going to be equals to 4 times 3 to the power 9. Then what do we get, guys? We're going to say 4 times 3 to the power of 9. We get 78,732. 78,732. That becomes our value. Okay. Let's see here what we have again here. We have got 1 over 2, 1 over 4, 1 over 8, 1 over 16. Now, remember what I taught you guys, treat them separately. So what do we have at the numerator? So the numerator is constant. So we don't need to worry about it. So we're dealing with the denominator here. So denominator is the one that is varying. So denominator have got a specific pattern. So deal with the denominator only here. You deal with the denominator only here. Only the denominator. So, but remember to keep your numerator on top. Okay, whenever you write your final, our general term, let's look at it and see. So when you look at the term here, we say T2 divided by T1 is going to be equals to 4 divided by 2, which is going to give us 2. Then what we call 3 divided by T2 is going to give us what we call 8 divided by 4, going to give us 2. Then T4 over T3 is going to be equals to 16 divided by 8, which is going to give us also 2. So what is a common ratio here? Our R is equals to 2. Our A is equals to 2. Can you see that we are keeping the numerator out of this for now, because we know that the numerator remains the same and it's going to be 1, 1, 1, 1 continuously. But we want to check what is the changes in the bottom. How do we determine the value from the end, what we call at the bottom? So let's see what we get. Now it's going to be T n is equals to A R n minus 1. What is our A? Is 2. What is our R? It's also 2. Then we have got n minus 1. So we can just put so that we can maintain the same thing here. So put in the bracket is T what we call 2 n minus 1. Then it's gonna be that's your general formula there. That's your answer that we want. This is the answer that is needed. What about T10? T10 is going to be equals to T. Why am I writing T now? It's going to be 2, then 2 to the power of 10 minus 1, which is going to be equals to 2 times 2 to the power of 9. What do we get here? 2 times 2 to the power of 9. We get 1024. 1024. I've made an error here. That error, just to correct you here. Yes, we are getting. So let's keep it this way. Let's keep it this way to say 1 over Tn, so that we won't have much of a problem. So 1 over that, then it's going to be 1 over 2 times 2, okay, n minus 1. So that's what we have here. So it's going to be 1 over that. Then here T10, we'll put the 1 on top here. Then you also put the 1 on top. Then this one here, we can quickly rub it. Your answer will be 1 over 1024. That becomes the answer. If we are to check to look for T20 or T30, it's going to be T30 is equals to 1 over 2 times, we don't put this one. Sorry about that. So it's just gonna be Tn there, but we put it as in this form now. 1 over 2 times what? We're going to have 2 here. What call 30 minus 1, which is gonna be equals to 1 over 2 in bracket here, 2 to the power of 29. Then what do we get as a final answer here? If we say 2 times 2 to the power of 29, we get a big number there. Oh, this number is too much. But you can see it's 107,374, 107,374, 1824, 1824, and we have 333. So this is more like 1 trillion, this one, but otherwise, this is the answer that you get. 1 over, okay, 1 over this value. Okay, let's move on to the next slide. Now, other questions also, you see that you don't have a formula to use. You are not given a formula to use. You just need to think, how do we get to this? So, for example, let's take the first one here, 1, 4, 9, okay, 149 skissed in there. Then if you have to check these values here, how do we check here? If we say 4 minus 1, you get 3. 9 minus 4, you get 5. If you say 4 divided by 4 over 1, you get 4. If you say 9 divided by 4, you get 9 over 4. So there's no constant ratio, there's no constant difference. So no common ratio, no common difference. So what must we do now? You must think, okay, how do I get this one? This one, you can say this is 1 squared, this is 2 squared, this is 3 squared, this is 4 squared. And remember here we're starting from term 1. So it's T1, T2, T3, T4. But what are we doing here? On the T1, we're just saying 1 squared, we get 1. 2 squared, we get 4. 3 squared, we get 9. 4 squared, we get 10. So how would we get Tn now? Tn is going to be equals to n squared. So if you want to get 100th term, you're going to say T100 is going to be equals to 100 squared. Then 100 squared is what? 100 squared, 100 times 100, which is 100 squared there. We're going to get 10,000. So it's going to be 10,000. Okay, so if you want any T20, T40, it's just going to be 40 squared. Okay, let's look on another one here that we can have. Let's have the 2, 5, 10, 17. How do we get these values? Let's try to think together here. 2, 5, 10, 17. What can we do to get 2? What can you also do again to get to get 5? Okay, if we are to say 1 plus 2 to the power 0 is going to be 1 plus 1, we get 2. Then if we say 1 plus 2 to the power, what is it? 2 to the power 1, we get 3, which is wrong here. So if we say 2 squared, 2 to the power, so if we say 2 to the power 0 plus 1, and 2 to the power 0 plus 1, to the power 1 plus 1, and the 2 to the power, what is it? 2 plus 1. Do we get the answer here? It's going to be a challenge again, because this one will get 3 here. So it's not part of it. So we can erase it and try to think which one how can we get the value? How can you get this one here? Okay, what if we say the first term is 1? So here let's have Let's have our T1 there just to label T1, T2, T3, T4. So if we say 1 squared plus 1, if we say 1 squared plus 1, 1 squared plus 1, we get 2. If we say 2 squared plus 1, we get 5. If you say 3 squared plus 1, you get 10. And if you say 4 squared plus 1, you get 17. So in this case here, it means that whatever term that we're looking for here, n the term, we're just going to say n squared plus 1. So our Tn here is going to be equals to n squared plus 1. Okay? Then in this case here, what are we going to do? We're going to say that's your general term. That's the first answer there. What about the 100th term? We're going to say T100 is going to be equals to 100 squared plus 1, which is equals to 10,000 plus 1, which is equals to 10,001. Okay, 10,001, that becomes our value. Let's try to find something else again here. The question 4, which is 5, 8, 13, 20. So the hint here is just there must be an n squared there. There must be an n squared that you are dealing with. So in this case here, you can say, if we say to get 5, how do we get 5? If we say 1 squared plus 2, you won't get it. How do we get this one? Let's try to think here. Okay, so here, if we say 1 squared plus 4, let's use another color here that we can understand here. If we say 1 squared plus 4, you get 5. If we say 2 squared plus 4, you get 8. If we say 3 squared plus 4, you get, 13. If we say 4 squared plus 4, you get 20. So here is the hint here. Whatever you be doing here is either you are saying, you are subtracting, you are adding, or you're subtracting. So it's going to be n squared minus 1, n squared minus 2, or n squared plus 1, n squared plus 2. It goes on like it's either way. So when you see what gives me the value, but the n squared must be there. Now let's see here what we have here. If we have got 1 squared here plus 4, we have got 5. So it means that our formula here should be, what is constant here is 4. So our Tn should be equals to our n squared plus 4. It's going to be n squared plus 4. So if you want to find the T100, the 100th term, it's going to be 100 squared plus 4, which is equals to 10,004. So it's 10,004. That becomes our final answer. So here is the hint here. It's either you're adding or you're subtracting. Let's look at number 5 here. This is number 4. Let's look at number 5 here. It's 0. Let's use a different color so you can see. It's 0. It's 3. It's 8. It's 15. Can you see what we have here? If we say 0, to get 0 there, if we say 1 squared minus 1, then if we say 2 squared minus 1, if we say 3 squared minus 1, can you see 4 squared minus 1? So 1 squared minus 1 gives us 0. 2 squared is going to give us 4 minus 1 to give us 3. Then 3 squared minus 1. 3 squared is 9 minus 1, you get 8. 4 squared is 16 minus 1, you get 15. So here you can see that our Tn in this case here, our Tn is equals to n squared minus 1. Then in this case, if you want T100, I'm going to say T100 is going to be equals to 100 squared minus 1, which is going to be equals to 10,000 minus 1, which would give us 999, which is 9,990 9. That becomes our value. So here is the hint here. If ever you find that my sequence the second that I'm given, there is no common ratio. So for example here, so in this case here, this one here, there is no common difference. Then again, no common ratio, because you just try before you start. You just say, okay, 7 minus 4 is 3. 12 minus 7 is now what you call a different value, which is going to be 5. But now 3 and 5 are different, so common difference out. Okay, 7 divided by 4 is going to give us 7 over 4. 12 over 7 is going to give us 12 over 7. Are they the same? So common ratio out. Now, what do you think of now? You think of the n squared now, where you're going to say n squared. So what do I say n squared here? Which is going to be, what's going to be my n squared? N squared what? Plus it plus 1 minus 1. Is it plus 2 or minus 2? You check there, then you can get your what you call your value. Okay. So guys, that's all for today. That's all for your number patterns for grade 10. If you have any questions, I'll also give you some practice work, what call on the Google Classroom. I'll upload some work there that you can actually practice. Okay, but I want you guys to practice with number 6 here and also with number 3 and send me what call the answers. Okay, thank you so much. Until next time, all the best.